Welcome to Advanced Broadcast Technology. I'm your host, Pallab Chatterjee. Today we'll be featuring another educational session that's focusing on a presentation by the SRT Alliance, which was founded by Wowza and Haivision and announced at NAB 2017. SRT stands for Secure, Reliable Transport and is a new protocol for delivering media. The talk will be focusing on the challenges of the media transport at all levels of the production process, as well as the solutions that are being provided by the protocol. The talk will also discuss the current industry participation on the program and ways that new companies can get involved in both producing hardware and software that can benefit from this technology. I'm pleased to introduce today's speaker, Chris Michaels, who's the streaming industry evangelist from Wowza, who will be able to tell us about the product. Chris?
Thanks, Paul, for the great introduction. Pleasure to be here to talk about the SRT Alliance and all the great things that we've been able to develop. As you said, I'm here with Wowza, and we've partnered with Haivision to launch what we've called the SRT Alliance. This is an open source initiative, really to bring the SRT protocol, which was a proprietary protocol that was originally launched by Haivision a few years ago, out to the public so that anybody along the full streaming ecosystem, whether it be an encoder or a decoder or anything in between, can then implement the technology and make it open source. We really hope that this can be a new open source standard for low latency delivery, something that can have better encryption and better security, but also reliable transport so that you can have the highest quality picture available through degraded networks and the public internet. So what is SRT? Well, SRT has a simple acronym. It's Secure, Reliable Transport. It's secure because we're able to now implement a new level of encryption over your video streams. You can have 128 AES encryption, but you can also at the insight or the endpoint have better control over what firewalls you're opening, so you're not opening a standard firewall. It makes it really simple to have point-to-point transport of video files, metadata, and everything that goes along with your video, audio, metadata, without having to use common port authentication. You can also have the reliability of being able to deliver across UDP. UDP has a great ability to send files over, but have the same TCP-like forward error correction to make sure that your video quality maintains at a highest level possible all the way through your workflow. And you have the full transport. You're able to send from end to end, whether it be point to point to a cloud infrastructure, up to a CDN if you're using a CDN for broader deployment. Now you have a better way to transport your video without having to rely on high chatter, high jitter type of infrastructures. Now, we started with just 2 members. At NAB this year, it was ourselves and Haivision that said that we wanted to come together and make this an open source initiative. We've had tremendous amount of response from the community. Everybody from Bright Cove and Limelight Networks, Global Links, Harmonic, Radiant, even cloud-based editing platforms like Lightstream have joined to say there's real potential in what SRT can do for helping streamline our workflows, helping make things deliver at much higher quality, but at the same time making sure that they can reduce the amount of bandwidth that's required in order to deliver really advanced streams. Now, I mentioned that every type of company within the streaming workflow can benefit from using SRT. Haivision, being an encoder and decoder company, really set the forefront in being able to do it on the hardware side. But then we also have players, mobile apps, and set-top boxes. Now, I also mentioned that everybody within the streaming workflow can benefit from implementing SRT. It started with Haivision with their encoders and decoders, and that's just the hardware side. We're also looking at players, mobile apps, and set-top boxes being able to deliver for your OTT streams. You have eCDN possibilities for people who are delivering within the enterprise and want to go point to point, like I said earlier, opening up a small firewall so you have less exposure and a secure transport. You have gateways, transcoders, recorders, and of course enterprise video platforms that can all benefit from implementing SRT along the way. Now, What makes this a great open source initiative? Well, first and foremost, it's open source, right? This is something that anybody can take the source code off of GitHub and build upon it. They can build applications. They can build it into their managed services. They can build it into the hardware. Really, by allowing SRT to proliferate throughout the entire workflow, anybody can build upon it and take full advantage of it. We have pristine quality. Now, we'll show a video in a little bit that shows how exactly you can deliver an H.264 or H.265 HEVC, which is now standard among many of the processors that are coming out. You can deliver that highest quality possible at very low bandwidth requirements with 2% packet loss. You can't even tell. With 2% packet loss on UDP with forward error correction as it was many years ago, you can absolutely see what the impact is. But also you're able to take advantage of very, very hyper low latency delivery. Within a Haivision specific use case, we've seen latencies as low as 550 milliseconds from point to point, from encoder to decoder, with as many as 50 milliseconds included per hop as you go through an entire network. So going from Berlin to the offices in Montreal, you're able to have super low latency, which means excellent applications for enterprise video or communication platforms, or anything that also needs to deliver high quality video with metadata that is time synced, so that you can have not only captioning but chat or any type of interactive elements that need to go along with the video at super low latency delivery, so that now you have the best of what we like to call streaming plus experiences. They're video plus data, video plus interactive, which we're seeing more and more applications rely on those types of deliveries. You also have very, very secure streams. With end-to-end 128 or even 256-bit AES encryption, you're able to make sure that your content is protected from the point of content contribution or where the origin is, all the way through the distribution chain. But being open source, we're not bound by by one specific company. Let me try that again. But also being open source, we're not bound by one company's specific monetary goals. This is not something that has to be licensed. This is something that is given to the community. We want people to build upon it. We want people to create new experiences. And these are things that, the creativity of the community is far beyond our own imaginations. We want to see what people can come up with it. So we're going to show a video here in just a second with Peter Mogg, the CMO of Haivision, and the Chief Revenue Officer, Carlos Perez of Wowza, as they come together to talk about the founding of the SRT Alliance and our hopes for the future.
SRT is a technology that Haivision developed for performance streaming across dirty networks like the public internet. It stands for Secure, Reliable Transport, and it combines packet loss recovery, encryption, and network health detection in a single deployable package.
The challenges of latency, the issues that are involved with packet loss, quality, with security, those are the challenges that we're looking to address, and we see this as the start of that process, and the two partners starting the journey.
The ultimate goal of the SRT Alliance is really to foster partnerships, to foster a de facto standard within the industry to solve the high-performance streaming requirements that everybody's after today. Right now, the industry, the solutions that are present to address that are very fragmented, and what we really want to do is drive adoption, get as many people on board as possible, get the creative minds in the market to contribute to the open source initiative and drive the technology further.
Open source is a great answer to competing standards, competitors pushing different ways to address this issue. Wowza is looking for industry-wide answers, and with our partner Haivision, we believe open sourcing is the way to go.
So the next steps are the continuation of that process to get the open source community, to get everybody interacting with SRT and driving it towards standardization.
Now, those are some great insights from both Peter and Carlos, as they have a wonderful vision for where SRT and this alliance can go. Now, one thing we haven't talked about, and Peter mentioned it here, is some of the constraints of why you would want to implement SRT. First of all, there's a lot of problems within the public internet, or as Peter once called in our press conference, the nasty networks, that prevent high quality video from being transported. The first and foremost is, well, you might be using a public internet point like a Starbucks local Wi-Fi, which might have a lot of congestion because you have a number of people that are connecting to it. You might also be connecting over mobile networks, and you never know the quality of a mobile network when you're just the individual who might be broadcasting across a mobile network. You might have congestion for one. There may be security concerns. There may also be may also be backhaul considerations for the mobile network that constrain your ability to send high quality video. Some of the impacts of that are packet loss, which are packets being discarded by the routers. You're not getting all the information to make a clear picture. If you see here, in this image, and this is just a graphic rendering, and we'll see real renderings later, this is something you can't really see all of the picture. It's not quite clear. It's something, even if you loaded up a stream today, you might start with a real jittery package and then it clears up later. But this can happen over traditional UDP, even with forward error correction. You also get jitter, which might mean packets arriving at different times. You may also have latency considerations. If you have a high network congestion at one end or at either end, it might slow down your ability to get a high quality stream, build the correct buffer sizes, and be able to have good playback. And lastly, bandwidth. You might have fluctuating bandwidth either from the source or the destination or anything in between, especially if you're delivering up to a cloud service, out to a CDN. You may have varying bandwidth constraints. So if I'm out in the bush in Australia, or if I'm in San Francisco sitting across from a major tech company, I'm going to have very high degrees of bandwidth either sending or receiving from either location. Now, packet loss is the biggest thing that impacts your video quality along the way. And there's a quick little image here, graph here. It says, how much packet loss you should anticipate having. Regardless of what your network quality is, you should at least plan for at least 1/1000% over an MPLS. You have 0.1% in a building, across the campuses, public internet on a good day or a bad day, and I have to qualify. That's also if you're sitting at a Starbucks in front of Google or the Starbucks in the middle of Des Moines, Iowa. Each one's going to have a different bandwidth constraint on that particular day. Now, we said it helps everything along the value chain. So SRT can be implemented from the camera or encoder, like a high-vision Makito encoder. It can be implemented across the network, so this could be your CDN, it could be a cloud service provider, it could be any sort of managed cloud delivery service, down to the decoders, and finally to the player side. So we talked about what can be transferred within that. Well, we have video and audio, and of course metadata. That could be your captions, it could be data that's being sent along, it could be even time-synced Twitter feeds that might be happening at the same time as an event. If you're bringing all that data in, all that audio and video, now you're able to deliver it in a seamless fashion and get it out there. We also have built into SRT package acknowledgement or forward error correction. So there are algorithms built within SRT that says, hey, we missed packet 9 or we missed packet 14, and go back and request it. Now, built within SRT is numerical value or at least composition orders, so that you can sit there and trust that we're not going to guess where this packet has to go in its assembly, and it's going to be delivered with the next packet when it comes through. So that jitter that we talked about earlier, the packet loss, much of that is completely corrected by having SRT built in there. We have the encryption there that we talked about, and the network connection characteristics that we're already accounting for and planning ahead to make sure that when something happens down the line, it's already adjusting. There's an intelligence within the SRT protocol. Also, it's firewall friendly. We said that you can build a specific solution that opens up, say, port 5000 if you want port 5000 to be your designated SRT port, instead of using ports that are defined for WebRTC or standard RTMP or HLS delivery. You have your dedicated port that you define for your security. But it's also bidirectional. So you want to use an IFB and have a talkback capabilities for a contributor who might be sending something out from a remote location, then you've got the opportunity to also have the talkback. So we're going to bring up a video here that shows you 4 different renderings of where SRT really helps in your delivery or your transmission. So in the bottom left here, you see a live source. This is a really cool rally car race. This is something that's coming straight off the camera, straight into the encoder. If I were to deliver just straight across with H.264 UDP connection with 4 megabit per second uplink, right? This is a very, very total bandwidth 5,000 kilobytes per second. If I'm delivering this, you can see under UDP, even with a forward error correction, I'm getting a lot of jitter. I'm getting a lot of packets that are being misorganized, and the image just really is not clear at all. If I go back, sorry. If I look at the top right or the bottom right, I'm seeing very clear image that comes from having SRT implemented at 5 kilobits per second or 5,000 kilobits per second or 3,400 kilobits per second. But you can also see I'm delivering H.264 with SRT in the top right corner, or I'm delivering HEVC, which is H.265, now standard on many of the new AMD chips and chipsets that are coming out, at 2.7 megabits per second. So even lower bandwidth constraints, I'm able to deliver a very high quality video without worry about jitter, without packet loss, without anybody realizing that this is being delivered over a low bandwidth network. So I mentioned delivering over a low bandwidth connection. There are many ways that you can actually send your videos. First and foremost, we talked about having your camera or encoder. At some point, we're hoping SRT makes its way onto the camera, so you may not even need a separate encoder to deliver. You can actually deliver over an IP camera or straight through into your cloud workflow. But then you deliver straight into the public internet, your SRT-enabled gateway, or might be something operating on AWS or Azure or Alibaba, or a private cloud service, even Google Compute. If you're using Wowza streaming software or Wowza streaming engine deployable software, you might even have an instance that is SRT compatible and you can deliver straight into your cloud infrastructure. You can take that and send it out to your production suite, into an editing bay. You can send it to a head office if you are sending something to a private or ECDN type delivery, or remote offices. So you're now able to send it to the cloud, enable cloud infrastructure, and route that directly where you want it to go. Makes it really simple to scale out your infrastructure and minimize your bandwidth constraints, because now you don't have to have dedicated bandwidth to have very high quality video delivered to all of your different endpoints. And the best part is, if you're delivering to a production studio, you can send that back out to the public cloud and deliver out after you've already composited your video, you've gone through your TriCasters, you've gone through any sort of editing solutions to make sure that now you've got high quality video coming in to your edit bay and even high quality video going out from your edit bay with very minimum bandwidth constraints. One other thing about being able to deliver the high quality is now you look at the virtual reality community that wants to also take it into an editing bay and stitch and composite real-time video, even 360 video. One example, a client of ours actually did a 3D or 360 degree production of the Beauty and the Beast premiere and put a 2D image in there and screenshot or screen in screen or picture in picture of the 360 degree video. And they're able to take all that video up in real time, add a compositing layer, and then send it back out to Facebook and YouTube and all the other places that they wanted to deliver without having to worry about the bandwidth constraints there on site in front of the Grauman's Chinese theater. You know, those are the types of events where you're out in public, you don't have to have a sat rig, and you can really have high quality video being delivered. Now this is just a quick snapshot of SRT in action. This is long haul video going straight from Hong Kong to Paris. Without SRT, you see delivering over UDP, you got all that jitter and all that noise that happens from everything being composited incorrectly. But once you apply that SRT, this is NHK video coming from Hong Kong. It is crystal clear, and you're able to be sure that your delivery is going to be accurate, frame rate accurate all along the entire workflow. Now, how do you implement SRT? Well, there's a number of great implementations and guides that we have up on the SRT website. But first and foremost, go to GitHub and download SRT. It's free, it's open source. You don't have to pay anything for it. You can go and download it. Don't sign an agreement, just look at it and understand that you're getting it under the general use license. Second of all, join the community, support the community. Tell us how you're using SRT in your products. Where can we expect to see it? How it's helping your particular work case. But most of all, let the community and the overall community know that you have implemented it, because more people will want to use something that's going to require less bandwidth and something that's going to make sure that they have high quality video being delivered throughout their entire workflow. Also, when you join the SRT Alliance, you get the marketing support. We want to promote you. We put out a press release promoting the 22 companies ahead of time. But we want to make sure that you are being successful not only in your implementation, but how you communicate that to the rest of the world. SRT is going to go a long way. We see that more people want to bank on it for low latency delivery, high quality delivery, and make sure that it's absolutely the best option for the future of video tomorrow. Also within that marketing support, we want to make sure that you have everything possible, including this logo. This is something that you can put on all of your products that say that it's SRT ready. It's something that you can tell your community of users that you are now implementing SRT into the products that you're making, and then they can use into the wonderful productions that they're creating as well. We invite you to join SRT Alliance. Come to our website, srtalliance.org, find out more information, download on a GitHub, and we look forward to hearing all the wonderful things that you're making. Thanks again for the time.
Thank you, Chris. As Chris had mentioned, the SRT Alliance now has over 20 members that are working and involved in this program, starting with the founders, Wowza, which is a hardware and software solution provider for internet streaming and broadcast. They work with television broadcasters, they have a mobile SDK, they have server technology, as does their partner Haivision, which has a media platform for the enterprise, so you could do cross-facility or broadcast on IPTV. The code is available on GitHub, and as you can see, there's quite an extensive listing of products that are available under this source environment. Their partners in the hardware space include Radiant, which makes an industrial rack mount line of encoders and decoders, Robotniks, which is also in the encoder and decoder environment, targeting live and real-time applications with solutions that include 4K that will be using the transport. MediaStar from Cable Time, which is focusing on digital signage and IPTV with streaming content. Kitzel Picked Off TV, which is a CDN for SD through Ultra HD quality content that's being delivered through a hardware software platform. Harmonic, that's looking to use the new protocol in their VOS 360 channel in a cloud broadcast technology. Then we have KepTech, which is a streaming video solution that includes file security and distribution on Wi-Fi. Churchill, which is a specialty supplier for broadcast that's targeting the law enforcement, emergency response, firefighter, and other time-critical matters. We have Tulix, which is providing corporate and education streaming solutions that are live, as well as House of Worship. Then we have T21, which once again is providing encoders and transcoders for the live environment community. Switching to software, we have Perfecta Federal, and Perfecta is focusing on the cybersecurity, intelligence, and encrypted video marketplace. Lightstream, which is focusing on the gaming marketplace with a specialty engine and wizards for supporting Twitch and other gaming interfaces. Bright Cove, which is a corporate live event platform for IPTV that provides a scalable infrastructure for live programs and webinars. Then we have Global Links, which is allowing people to do global interviews for news without having to dispatch teams through their CDN environment. Limelight is also a CDN that's focusing on the quality of experience and high performance and high reliability imagery. Then we have Global News Alive, which is a service for having their reporters provide content to the news media without dispatching a crew. Crest 21 has a live workflow that works in SD through Ultra HD. Then we have Perform Group, which is focusing on the professional sports marketplace of multi-camera and high reliability live streaming. VirtueVent is once again targeted to the enterprise marketplace for conference events for associations, publishers, and corporate communications. Then we have the Skipa TV, which is also a media company that's focusing on IPTV, local and small area event locations. And finally, Softellum Corporation that has a transcode environment and streaming control environment that reside in software in the cloud.